Well, I hope everybody had a great time and just be able to kind of relax and just get away from school for a little bit as much as possible and all of that. So, we're jumping back in to 5.4. So, and this will be a little shorter, okay, and it's shorter for a reason, but this is dealing with the multiple angle identities. Okay, and we're not going to do much with them. More just want you to be aware of them because they are important for you to know, but not something that I really feel we need to spend a ton of time doing and using in here at this point, just with other methods that we have and stuff, but I do want you to be aware of it so that you've seen them should they come up again. We really don't even use them all that much in calculus, but like I said, they're in our textbook. They are important. You should have seen them last year in Algebra 2. So, double angle identities. So there are 5 of them. And so the first one, okay, the sine of 2, I'm going to use theta. Sine of 2 theta is equal to 2 sine of theta cosine of theta. So basically it's saying if you have the sine of a double angle, then you can rewrite it in this fashion here. It's pretty much all these are doing. And cosine then of 2 theta, okay, it has 3 possibilities. So the first one is that you could rewrite it as a cosine squared of u minus the sine squared of u. Another option, you could write 2 cosine squared of u minus 1. And your third option would be to write it as 1 minus 2 sine squared of u. That you can write those ones. I think it might have just frozen a little bit in the video. If it did, I apologize. It's been messing up a little bit today. And then lastly, we have the tangent of 2 theta, which is equal to 2 tangent of theta over 1 minus the tangent squared of theta. So those are your double angle identities. And we have some half angle identities next. So those are, one second. So with these ones, again, we have the same, well, we have 4 of them, actually, 5 of them. Forgot about one of them. So the sine of theta over 2 is equal to plus or minus, okay, and the sine and the cosine ones will be dependent on which quadrant they're in, okay, is equal to the plus or minus the square root of 1 minus the cosine of theta over 2. Also just realized up here I was writing u's instead of thetas. I don't know why I was saying that and writing that, but they're all supposed to be thetas, so sorry about that. Alright, down here, okay, the cosine of theta over 2 is equal to, again, plus or minus the square root of the difference here is it's 1 plus cosine of theta over 2. And then tangent has 3 possibilities here, so the tangent of theta over 2 is equal to, so first possibility is plus 1 minus the cosine. I would assume you would notice that that is because tangent is sine over cosine, and the 2's would cancel if you did that, and so then that's what we'd be left with. So I presume you see that, hopefully. Another option here, much for the same reason, would be 1 minus the cosine of theta. Again, I'm writing u's. 1 minus cosine of theta over the sine of theta. And then another option would be the sine of theta over 1 plus the cosine of theta. Okay, so those are just some other options that we have there. And then the last type that we have, I'm just going to write them over here, they are the power-reducing identities. And these are ways to rewrite things that are squared. So sine squared of theta is 1 minus cosine of 2 theta all over 2. Cosine of 2 theta is 1 plus the cosine of 2 theta all over 2. And lastly, the tangent squared of theta is equal to 1 minus the cosine of 2 theta over 1 plus the cosine of 2 theta. Okay, so you can kind of see a similar pattern here with these ones. For them being squared, basically you're just taking the square root is the only difference over here with those. So, those are all of those identities that you need to be aware of. Okay, if you are quizzed on them, it would be the extent of, tell me what the double angle identities are, tell me what the half angle identities are, or tell me what the power reducing identities are. There would be no actual homework with this section. It is just more of a make you aware of it, understand it, in a sense of the formulas, just know the formulas, and know that we can use them to help us rewrite things that we need to rewrite. So that's all for that for today.